Today is the seventh experiment, okay, and we are going to learn just Gauss elimination. Yes, in the last lab, what we have learned? Hmm? Gauss elimination method, isn't it?
Yes, sir. Gauss elimination.
Here we are going to learn Gauss
Gauss
seidel
Seidel.
method, and here the same job is going to be done by this method, okay, and it's one of the most popular iterative methods to find the solution of linear equations. And it's not going to take that much time. Code is also very small. Okay, hopefully within half an hour we will be able to complete, inshallah. Okay, let's see. So today we are going to get familiarized with Gauss-Seidel method. Okay, which will work. The same job will be done by this one. Okay, which was done by elimination method. And you can see in the last lab we have solved this equation using elimination method. Actually, this is a iterative method. Okay, Gauss-Seidel method is a iterative method, and this one was simply we were uh, eliminating one variable, that means one unknown. So in this way, at the end, only one unknown were remaining. So from that one, we used to find the last unknown value, and after that, gradually by back substitution, we used to get the solution. Okay, no problem. The same job will be done here. And it's a most commonly used iterative method, and it solves the linear system of equations. You know all these things, I hope. And it can be applied to any matrix with non-zero elements on the diagonal. Okay, that means if the elements are like this, then the diagonal elements, if they are non-zero, then it can be applied, and the convergence is guaranteed only if it's diagonally dominant. Not diagonally dominant, then the convergence is not guaranteed. Okay, so I hope all of you know what diagonally dominant is, but I'm going to just show you a little bit because people like, so a square matrix, it should be one square matrix. A square matrix will be said as diagonally dominant if for every row of the matrix the magnitude of the diagonal entry, okay, the magnitude of the diagonal entry, suppose 3. Suppose if the matrix is something like this, okay, the magnitude of the diagonal entry. Suppose this is the diagonal entry for the first row, okay, and this is the diagonal entry for the second row. This is the diagonal entry for the third row, okay. So if the diagonal entry in a row is larger than or equal to the sum of the magnitude of all other non-diagonal entries, that means for this row, this is the diagonal entry, and it should be greater than sum of other two elements. In the same way, so greater or equal to, okay. In the same way, for the second row, this is the diagonal element, and it should be greater than or equal to the sum of other two non-diagonal elements. In the same way, for the third one, for the third row, this is the diagonal element, and it should be greater or equal to the sum of other two non-diagonal elements. Okay, very simple definition, and it can be written in this way. Okay, AII, that means this same. What should I say? Both of the row and column number, they will be same. So it will be greater or equal to, okay, then all other non-diagonal elements. Okay, and you can see this condition will be fulfilled if j is not equal to I. Okay, because if j is equal to I, then that will be a diagonal element. Okay, so you know very well these things. Okay, now, so if this condition is fulfilled, okay, if only this condition is fulfilled, okay, then we can tell it as weak diagonal dominant. Okay, that means weakly diagonally dominant. Okay, but if situation is something like this, that all the AII, okay, that means this condition is valid for AII greater than, only greater than, strictly greater than the non-diagonal, sum of the non-diagonal elements, then that will be called as strict diagonal dominance. Okay, so this thing is not needed. So two extreme point, one is the scenario is something like this, then this is actually weak diagonal dominance, and another is if all the rows are fulfilling this condition. Okay, this condition is fulfilled for all the rows, then that's actually strict diagonal dominance. Okay, but in general what we can consider, we can consider that for the first row, okay, for 2 rows, at least for 2 rows, suppose if the three equations are there, then for at least for 2 equations, this should be fulfilled, okay. So this should be fulfilled for 3, all the 3 rows, okay, and at least for 1, it should be fulfilled. Are you okay with what I am telling?
Yes, sir.
So there are 3 equations here, okay. Suppose if there is n number of equations, if there is n number of equations like this, 1, 2, 3, okay, 4, suppose 4 equations, okay, then obviously all the rows should be fulfilling this condition. All 4 rows should be fulfilling this condition. At least any one of the rows should be fulfilling this condition, okay. And obviously, if you ask me if this condition is not fulfilled, then the problem will be there may be solution, but the solution is not guaranteed, okay. You cannot guarantee, you cannot give the guarantee that I am going to get the solution. You may or may not get the solution, okay. If you want to get a guaranteed solution, then obviously you have to try to do this, you have to consider this diagonal dominant situation, okay. Now let's go for 3 examples, okay. So I have taken from the internet these things, okay. If you search, hopefully you will very easily get all these things, okay. Suppose this is A is equal to something like this. So here, this is the diagonally dominant element, okay, for the first row. For the second row, this is the diagonally dominant. For the third row, this is the diagonally dominant, okay. So you can see 3 is, and the sum of the non-diagonal elements is also 3, okay, absolute value obviously. So like this, so sum of them are 3 and the diagonal element is 3, so they are equal. So the condition is fulfilled, okay.
Yes, sir.
Now for the second row, this is the diagonal element, okay, the absolute value is 3 and the sum of the other non-diagonal elements is also 3, okay. That means 3 is equal to 3. This condition is also fulfilled, okay. Now for the third one, you can see this is the diagonal element 4 and the sum of the absolute values of the non-diagonal elements, that's also 3, okay. That means 4 is greater than 3, okay. So you can see all the 3 conditions are fulfilled. For the first one, okay, I have told that for all the 3 rows, this condition is fulfilled, and for at least one equation or at least one row, this condition is strictly greater than the sum of the non-diagonal elements. This is fulfilled. That means this is diagonally dominant.
Yes.
No, it's not diagonally dominant.
Yes.
So for the first row, this condition is not fulfilled, okay. For the first row, this is the diagonal element, okay. So the absolute value is 2 and the sum of the non-diagonal element is 3. So this is less than 3. So it's not fulfilling. The first condition is not fulfilling, okay. So directly we can say that this is not diagonally dominant, okay.
Yes, sir.
Now for the third case, first one, this is the diagonal element 4, okay, and sum of other 2 is 3. That means it's being fulfilled. For the second row, diagonal element is 6. Sum of other 2 is how much? Arunga?
Yes, sir.
So are you with me? Sum of the non-diagonal element is 3 absolute values, okay. So all of them are greater than the diagonal elements are greater than non-diagonal elements, sum of the non-diagonal elements, okay. So this is diagonally dominant, and we can also say this is strictly diagonally dominant, because this condition, strictly greater than condition is fulfilled here. So anyone, do you have any problem with this one? Anyone?
No, sir. It's okay.
Oh, very good. So let's go for one example, okay? So after example, we will be going for the main thing, and it's very simple. So half an hour will be enough, inshallah. So now, one example has been taken where equation number 1 is this, 2 is this, 3 is this, and you can see 3 unknowns are there, okay? And the solution is something like this. Already, suppose by calculator, I have found the solution something like this, okay? Now, at first, what I need to do, I need to find the diagonally dominant form, okay? So for that, what I need to do, if I just simply shift these equations, okay, suppose now equation number 2 is given at first, then 3, then 1, then you will be able to see that it has got the diagonal dominant form. Now you can see the diagonal dominant. Here the diagonal dominant form is not fulfilled. It will be found out with respect to z and x, and z will be found out with respect to x and y. Okay, so we have simply separated them. After that, what I will do, I will go for iteration. Okay, let's see how we have done that. So already you have seen that we have separated x, we have separated y, and we have separated z, and they are something like this. So then what I need to do, I will simply take some initial gaze. Okay, so one good gaze may be something like this, 0, 0, 0. Okay, then our calculation will be told that already we have found x, y, and z. Okay, so after that, at first our job is to find the diagonally dominant condition. Then number 2 is to separate the x, y, and z from the diagonally dominant condition. And number 3 is we need to initially guess 3 values for each of the variables. Okay, so one very easy way is to take 0. Okay, and if I take even other values, that's not going to be a problem because computer is going to handle, because it's 3. Okay, so number of equation is 3 in this case, but it may happen that I have 10 unknowns. Okay, at that time handling with the help of hand is not easy. Okay, so here I have taken 0. This is a easy assumption. Okay, so during the initial guess, okay, so my initial values are all okay. Now I will go for iteration. So during my first iteration, what I will do, I will simply use these equations in the iterations. Okay. Computer is lagging. Okay. So here, first, I will find the value of x with the help of initial guesses of y and z. Okay. So here x will be found out with the help of these previous y and z. Okay. Initial guesses y and z. That means I will put 0 here. I will put 0, 0 here. After that, sorry, y and z I will put 0. After that, I am going to get x is equal to 4 by 5. That means 0.8. Are you okay till now?
Yes, sir.
Yes, sir.
So now, after that, I will find the value of y. I will find the value of y. How I am that value? I will consider, because to find the value of y, I need the value of x and z. Okay, so I will use the recent x value. Okay, recent x value and previous z value. Okay, initial z value. These two values will be considered to find the value of y. In the same way, to find the value of z, what I will do, I will use, because to find the value of z, I need the value of x and y. Which x and y I will use? I will use the recent most x and y. Okay, that means this y and this x. That means 0.8 and 0.3. Okay, so if I put all these values, then you will be able to see these are the values. Okay, so after first iteration, you will be able to see that the value of a, y, and z is something like this. Are you okay with the first iteration? So in the same way, during the second iteration, whenever I will be going to find the value of x, at that time I will use the most recent last value of y and z, because to find the x I need y and z value. So which y and z will I use? I will use this y and this z. Okay, these are the most recent values. So whenever I have an updated value of x, suppose whenever I will be finding this value, okay, so why should I use these two values? Because to find the value of z, I need the value of x and y, isn't it? So I need the value of x and y to find the value of z. So whenever I am going to find this value, obviously I have the most recent values. These two values are available in my hand. Why should I go for other values? Okay, so in the same way, this is guess. Okay, at first this is guess. Okay, so I have guessed these values. Okay. After that, whenever I am going for the iteration, then I am going to find the value of during the first iteration, I'm going to find the value of x. Okay. So to find the value of x, obviously I need the value of y and z. Okay. So y and z, I have only y and z 0 and 0. Other than this, no value is available in my hand. Are you okay? So now, whenever I am going to find the value of y, at that time, I have recent value of x. Why should I go for 0 again? Okay, so I will use this x, and most recent value of z is actually this one. Because to find the value of y, I need the value of x and z. In the same way, whenever I am going to find the value of z, at that time I will use the most recent value of y and z, because to find the value of z I need x and y. Okay, so most recent x and y is this and this. Okay, so in the same way, during the third iteration, whenever I am going to find this value, I will be using y and z, because to find the value of x, I need y and z. So I will be using these two, because these two are the most recent value. In the same way, to find the value of y, I will be using the most recent value of x and z. So most recent value of x is this one, and most recent value of z is this one. So in this way, I will continue, and I will check the solutions. Okay, so that means the difference between x. Okay, the difference between them. So whether the solution is very close to each other or not. Okay, so suppose after 6 iterations, okay, so you can see after 6 iterations, the solutions, the x, y and z values are something like this. Okay, and if you compare between the previous values of x, y and z, then you will be able to see that 2 digits they are same, 2 digits they are same, 2 digits up to 2 digits. Okay, after decimal point, 2 digits they are same. Okay, that means if my tolerance is something like 0.01 like this. Okay, suppose absolute approximate error. Okay, so I'll show you the definition, no problem. So if the scenario is like this, then you can see this condition is already fulfilled. Okay, that means this is 0.00, the difference will be obviously 0.00 then something. That means this condition is fulfilled. Okay, so during the iteration, what I need to do, I will just check with the previous value whether they are close to each other or not. If they are close to each other, then up to our desired error, we will just go for iteration, and when we will be getting the desired error, then we will be fine. We will be out of the loop. Okay, we will be out of the loop, and we will be out of the iteration, and we will be having the value of x, y, and z. Okay, 0.55, 0.46, 2.18. Okay, something like this, no problem. So these are the solution. Okay, and if you compare with the solution that I have shown already, so they are almost same. First, our first job. Okay, suppose these are the 3 equations. Okay, given 3 equations. Then what I need to do? At first, my job is to make it, if they are not in a diagonally dominant form, okay, not diagonally dominant form, then I need to make it diagonally dominant at first. Okay, at first I need to make it then diagonally dominant. Then after that, what I need to do? I'll simply separate the x1, x2, and x3 from the 3 equations. Okay, where they are diagonally dominant. Okay, so if I separate x1, you will be able to see something like this. If I separate x2 from here, from this equation, if I separate x2, then you will be able to see something like this. And from this equation, if I just separate x3, then we are going to get something like this. What I need to do, I need to guess the values of x. Okay, so as you have seen that we have guessed 0, 0, 0. Okay, one simple way to assume is all 0. Okay, and these zeros will be substituted in the first equation, and from there I am going to get the value of x1. Okay, because if this is 0, this is 0. Okay, so then only b1 divided by a11 will be there. Okay, x1 will be found out by putting all zeros. Okay, after that we can substitute the new value of x1 and previous guess of x3 to find the x2. Can you relate with the example? To find the x2, I will be using the recent value of x1 that has been found out here, and also I need the value of x3, which will be actually the initial guess. Are you okay?
Yes, sir.
Yes, sir.
Okay. In the same way, we are going to find the solution for x3. Okay. So after this, whenever I have found like this, I will be iterating time and again, time and again, time and again until I am going to get my desired precision. Okay. So here in your lab sheet, they have given the definition of absolute relative approximate error. Okay, but in the code they have not used this one. Okay, rather what they have used, actually this one, absolute approximate error. Okay, so approximate error is this one. Approximate error is previous approximation minus present approximation minus previous approximation. Okay, like this, xi minus xi minus 1. Okay, or x new minus x old. Okay, so this is approximate error, and if there is a absolute sign, then it will be absolute approximate error. So this has been used in your code. Okay.
Yes, sir.
Any problem till now?
So this is the condition of the while loop, sir.
Yeah, you can take. You can
Yes,
use
sir.
this as a condition. No problem.
Okay.
So now, just one thing before I go to the code that is needed. So I have already shown that x1, x2, and x3, they will be found out something like this. Okay. So if you just can relate, you can see to find x1, obviously at the denominator there will be a11. To find x2, there will be a22. To find x3, there will be a33. Okay. So if I want to find the general term, because general term is needed to use in the code. Okay, to be used in the code. So if this is xi, then at the below, what will be there? Can anyone tell? It will be
AI.
Okay. Now again, to find x1, I need at first b1 minus something. To find x2, at first I need b2, then minus something. To find x3, I need b3 at first, then minus something. So to find xi, at first I need bi, then minus something. Are you okay till now?
Yes, sir.
Now, very good. So now, to find the rest of the portion, you will be able to see this is minus, all minus. Okay, so this minus a12 x2 plus a13 x3. Okay, so if you just observe, there is no a11 term here. In the same way, if you just see, there will be minus. So if I just take common, then there will be plus. Okay, so there is 21 into x1, but there is no a22 term. Okay, so there is no a22 term, as well as there is no x2. Okay, so this is not available here. Other than this, all other combinations are available. So in the same way, just wait. So in the same way, for the third case, there will be minus, and if I take common, then it will be plus. Okay, you can see that to find x3, okay, there is no x3 term here, and also a33 term is not available here. Okay, so one conclusion we can come that it will be summation of ai something, aij or something, and obviously x will be multiplied. Okay, it will be a sum of all combinations other than I is equal to j. Okay, that means both of them cannot be equal. This condition is not available here. This condition is not available here. Okay, both of them are same. This condition is not available here. That means it will be the summation of all possible combination of aij into x, but only remaining will be j is not equal to I. It will not be available in the summation. Okay, so whenever the number will be more, then 3 will be there, 3 summations will be there. When 4 equations will be there, then 3 summations will be there. When 5 equations will be there, then 4 summations will be there. Okay, when 6 equations will be there, then 5 summations will be there, but never ever there will be I is equal to j. That means always they will be summing up. Okay, but I will not I equal to j. This one will be only remaining. Okay, are you okay? What I just visualize this one. Okay, So
Yes,
it's
sir.
you have to understand by yourself. If I know maximum of you can understand very easily, but I am just helping you to visualize how they are working. Okay. So now this equation, how can I write this equation? This equation can be written in this way. Okay. In this way, you can see if I just take minus, okay, as their sum. Okay. So if I just divide it in two portions, j is equal to I minus 1, and after that, okay, j is equal to 1 to I minus 1. Okay, this region is summed here. Okay, summation has been done here, and after that, from I plus 1 to n, the remaining summation has been done here. Okay, so which one is left? I is equal to j is left. Okay, so I can simply replace this one with this equation, isn't it?
Yes, sir.
Just try to visualize what I have told. Okay, so even if you cannot understand properly right now, after the class, whenever you will just go through by yourself, hopefully you will not face any problem if you see the lecture what I have told. Okay, are you okay? So my target is not to just show you all these things. Okay, I can just in general what I am supposed to tell, I am supposed to tell that this is the general equation. Okay, this is the general equation. Okay, so with the help of this equation, we are going to find the code. We are going to use this equation in the code. Okay, so just I have tried to make you visualize how it has been, it can be obtained from the solution, from these solutions. Okay, so anyone, do you have any problem till now? If not, then I will go for the code.
No problem.
Okay, very good. Uh, So as I have told, so everything I have written before your class, because after taking one class, I have understood that if I write everything in the class, then it takes more time, and if it's more time, then your absorption capability reduces. Okay. So now CLC, clear all, close all. You know all these things. Okay. I want to solve this equation. The equations those were solved in the previous class. Okay. So I need to give. So here A is actually, A will be representing the left side. Okay. That means the A matrix is this one. Okay. 3 minus 1 minus 2, 3 minus 1 minus 2, like this. Okay. And if I want to give it as input in the code, then that should be written like this: 3 space minus 0.1 space minus 0.2, then there should be a semicolon, isn't it? Arun
Yes, sir. Yes, sir.
So in this way, I am going to give the input of A. So the right side is actually, this is A. The right side is going to be actually a column matrix, and this is B. Okay. So I am going to give B as the input here, and B will be simply like this. Okay. This is B matrix, and if I want to give this matrix as input, then it should be 7.85. Then there should be a semicolon. Then 19.3. Then there is a semicolon.
স্যার এটা যদি ডায়াগোনালি ডমিনেন্স না হয় তাহলে কি এটা আমরা আগে ডমিনেন্স বানিয়ে তারপর ইনপুট দিব?
Yes, here the code that we are doing in this code, actually the code is not made like this, that it can by default, it can it by itself it will be able to handle the uncertainties. Okay, rather what I need to do, at first I need to make it as diagonally dominant. Okay, so here you can see this is diagonally dominant because 3 is greater than these two, summation of these two, 7 is greater than summation of these two, 10 is greater than summation of these two. So I am not facing that problem. Okay, so if there were any problem like that, then obviously I should switch them, or I should do something to make them diagonally dominant. Now I have given the input A and B as the user. After that, tolerance is going to be given. Okay, suppose if I give tolerance 0.001, okay, the tolerance 0.001, then I will just give as the input. Okay, now as Shajit told in the last class, that why should I give the value of n? Okay, so here he told this one in the previous lab. Okay, so I can directly find from this equation what is the value of n. Okay, so n is equal to size of a comma 1. Okay, so it will give the row number of a. Okay, that means it will be 3 because 3 rows are there. After that, what I will do, I will just take x is I will consider x as a solution. Okay, so x, as I have told, I need to take any initial guess. Okay, so I have taken 0. Can you remember whenever I was solving the equations, I have taken 0, isn't it?
Yes, sir.
So here they haven't taken 0. That doesn't matter, okay? Because whenever I have done at that time, 0 was helpful for me to calculate by hand, okay? But computer is doing that one, so let them take the pain, okay? So I'm not taking the pain. So I'm not thinking of all those things, okay? So what I'm doing, I'm simply taking random values, okay? So I'm taking 3 random values, okay? You can see n is the number of row, n is the number of row, and 1 is the number of column. That means it will get 3 values in a column, okay, and that will be x.
Could we have taken zeros or
Yeah,
one?
you can take, no problem.
Okay.
It doesn't matter, okay. So random values. So what will be the output? So this output, the instruction, this instruction. So in the last class, one student told me to make the whiteboard clear. Who was that one? Who was that person?
Sir, 114.
112. Okay, very good. So after that, I have rectified myself. Now I am trying to, because after few steps, I make my whiteboard very. So you can see. So this one, okay, random. I have told that it will have 3 rows and 1 column. You can see 3 rows and 1 column. Okay. So again, if you just run this instruction in the command window, then you will be able to see again 3 values will be there and they will be defined. Okay. So it doesn't matter what value they are having in x. So they are the initial values. Okay, I have taken. After that, normal value. Okay, normal value has been taken as infinity. Okay. Okay, so any norm value, okay, so this is any variable that has been taken, okay, so it has been taken as infinity, okay, so tolerance, okay, so tolerance may be if this is 001, okay, so I will be tolerating more if the desired toleration limit is like this, okay, I will be tolerating more if the toleration limit is something like this, 0.1, I will be tolerating more if this is up to 10, okay, difference is up to 10, then the solution is not going to be perfect, okay. So that means, so this solution is not going to be perfect, okay. So if this is more and more, then the solution will be less and less perfect, isn't it? The less this value is, tolerable value is, the more precise the solution is, isn't it?
Yes, sir.
Yes, sir.
The more the greater the value. Suppose if this is the biggest value, infinity, okay, so this is, there is no possibility of finding any good value, okay. So why I am giving the initial value of the tolerance is taken as infinity, okay. So they have taken, because greater than this one, okay, it's not possible, okay. Actually, I am giving one tolerance limit, okay. I don't know what's the tolerable limit, okay. So the user may give 001, okay. The user may give 1. The user may give 1. The user may give 0.1, okay. So the safest zone is to use infinity, okay, because greater than infinity he is not going to give. Are you okay? What I'm telling? Why I am taking infinity?
Yes, sir. Yes.
Okay, just to compare here, okay. So even there are many other ways. Without comparing with infinity, many other ways are there, okay. So here they have done in this way, okay. So the maximum possible tolerable limit has been considered here, and it's always checking, okay. So okay, gauge iteration, that means this is the number of iteration is being checked here, okay. Number of iteration is going to be checked here. And why I have taken this variable as infinity, because every time I will be checking whether this is greater than tolerable limit given by the user or not, okay. So I have taken infinity, this is willingly. Why? Because the user may give 0.00000001, okay, because if the user wants very precise result, okay, but if the user is careless, he want to complete very fast, then he will give 0.1, okay. And if one's user, he doesn't know anything how the solutions are going to be, then just arbitrarily he's giving 10, okay, 100, okay. The solution is not going to be good, I know, but they may give. But the maximum value that the user can give is infinity, okay. So infinity is not going to be given by the user. Okay, that's why I have to stay in the safe position. They have taken this one as infinity. So are you okay till now? What I have told, just to use.
Yes, sir.
Yes, sir.
Okay, very good. So 114. Thank
The
you.
tolerance is the absolute error, right, sir? Absolute approximate error.
Yes. Yes. Just wait. My computer is not on. Okay. Very good. Okay. So can you see the screen properly? Everything written here.
Yes, sir.
Okay. So if this is small, just let me know. My computer is not working. Okay, now again I have told the code is very small and the main portion of the code is this one, okay, this line. So I am checking the condition, this condition, okay. So whenever my tolerance, whenever my difference or my approximate error, okay, absolute approximate error, okay, approximate error is greater than the given tolerable range, okay, up to then it will continue, okay. But when this condition will not be fulfilled, that means I have got my desired solution and it will come out of the loop, okay. And the end of the loop is actually this one, okay.
Sir, here we are only finding out x, not y and z.
Yeah, all
Okay.
three.
Okay.
Because x1, x2 and x3. In x, how many? Can you take?
Oh, okay. X is a matrix. Okay. Sir, বুঝতে পেরেছি. Yes. Okay, sir. Okay.
Okay, so for this loop or a computer, so this loop, okay, this loop will start from here and it will end here, okay. So here the loop is very big, but the main thing is only in this line, okay. Only in this line holds the main thing, okay. So if you see this one, xi is equal to bi, okay, minus, okay, xi, let me clear it. I'm done, almost done. 5 minutes, only 5 minutes, inshallah. Okay. So here you can see xi left side, okay. Right side at the bottom, what will be there? aii, okay. You can see 1 divided by ai. That means right side is also done. Okay. After this, in the above, okay, what is there? B minus something, okay. So bi is there, minus sigma. Sigma contains everything, okay. Sigma contains everything like this one, okay. So you can compare this equation with this one, okay. It will be better, okay. So you can see at the bottom there is aii, okay. At the bottom there is aii. At the above there is bi minus some summation, okay. That summation is considered as sigma, okay. So how can I find the sigma? Just from here I am going to see sigma, okay. Sigma will have sigma is actually this one. This one means this half portion, this portion, isn't it? Sigma means this portion means summation of minus summation of this portion. Are you okay? This two. Okay. Now if I go from j is equal to 1 to I minus 1, j is equal to 1 to I minus 1, sigma will be actually sigma plus, that means I am adding up aij into xi, okay. So in the same way, after that only I want to exclude j is equal to I want to exclude j is equal to I. That's why from here you can see j is equal to I plus 1 to n, okay. That means I plus 1 to n, okay. Then again same thing is multiplied aij and x old value. Okay, so at the very beginning you will be able to see x old was taken there. Okay, so x old, for each and every iteration x old is actually x. Okay, I'm updating the values. Okay, so you can see whatever here, whatever has been done here, that has been done actually to find the sigma or this portion, summation portion. Okay, to find the summation portion or to find the sigma. Okay, if you explore by yourself, you will be more clear, inshallah. Okay, so main thing is your this equation. Main thing is the last equation. Okay, so if I execute this last equation, if I iterate this last equation, okay, it will iterate. Okay, oh sorry, I have made a mistake. Okay, the while loop will just continue up to this. Okay, because within the while loop I have to increase the gauge number. Okay, that means iteration number. Also I have to find the norm value. Okay, or actually this is the absolute approximate error. Okay, so norm value will give us the absolute approximate error. Okay, so these two should be within this loop. Okay, so whenever this condition will not be fulfilled, that means we have found out one solution according to our desire, then we will be out of the loop. We will be out of the loop and we will be printing the solution. Okay, in the X the solution will be there, and the Gauss iteration, actually this will give the number of iterations, how many iterations we were in need. Okay, so if I just summarize, the whole code is very simple. One while loop is the most important thing, where the main part is this line. Okay, and in this line there is a sigma or this summation of aij, and to find this sigma I have executed another for loop. Okay, this one. Okay, so actually this one for loop for okay, so up to this one. So to find this sigma I have done all these things. Okay, so if you just go by yourself, hopefully you will not face any problem. There is nothing special here. Okay, so anyone, any problem?
ঠিক আছে স্যার
ঠিক আছে, বুলেটের মতো ফাস্ট।
লাইটের মতো।
Okay, listen, I have simply copied the whole code. Okay, I haven't changed anything. Okay, so let's run the code. So whenever I run the code, at first it is demanding the value of x. Okay, so x value was already given by me probably. Yes, x value is given here. Okay, so I'm giving the x value, then y value is also given here. Okay, y value is also given there, and let's take it as 0.001. Okay, so I have given the maximum approximate error. Okay, it's the absolute approximate error, no problem. Then matrix A and matrix B. So whenever I run the code, then you can see solution of the system is 3, -2.5 and 7. Okay, so if you can remember, in the last lab we got the same solution. Okay, and there are number of iteration that it